in a canister is normally distributed with a historical standard deviation of 0.35. Okay, the quality control inspector comes around. He wants 95% of the boxes to have 64 ounces of Tide or more. As long as it has the 64, we're happy. So what should the mean be set to on the filling machines so that the Tide boxes, at least 95% of the boxes, have that 64 ounces in it? All right. So here's the deal on this problem. This is a problem where we need to use z-scores in order to be successful here. So what I'm going to do is I'm going to use my inverse norm function to find the z-score for the value where 95% will be above that. So I actually want to be at 0.05 for the bottom. So my probability is going to be 0.05 because I want 95% of the boxes to have more than the value that I'm looking for. Okay? The reason I can't do this in the traditional sense is because I don't have the mean. So normally we would be given the mean and the standard deviation, and I'd be able to find this. I know the probability, and I know the standard deviation, 0.35, but I don't know the mean, and that's actually what I'm looking for. And so what I need to do is use my z-score formula. And if you remember, a z-score is going to be x minus mu, which is the mean, divided by the standard deviation. This is the formula that I'm going to use. So first I have to find z, because that's the only, if I'm looking for the mean, I need to know every other variable here. I know the standard deviation, it's 0.35. I know x, it's 64. I want x to be 64. And I can find the z-score using this probability. So I'm going to use my NORM.INV function. The probability is 0.05. The mean and standard deviation to find a z-score are 0 and 1. And that's going to return a negative 1.645. Now that's going to be equal to 64 minus the thing I'm looking for, which in this case is the mean, divided by the standard deviation. I'm not trying to make a formula here. So I need to solve this equation. It might be better to do that on a piece of paper here, but I'm going to go ahead and take out that piece of paper and use it. Okay, so I used Excel to find the z-score. The z-score in this case is negative 1.645. I'm going to set that equal to 64 because that's how much I want in each container, minus the mean over the standard deviation, which is 0.35. So how am I going to calculate the mean? Well, first I'm going to multiply by 0.35. And then I'm going to do the old switcheroo here. I'm going to add the mean to this side, and I'm going to subtract, which means I'm actually going to add this to the other side. And what I'm going to end up with is the mean being 64 plus 1.645 times 0.35. Now that's something I can do over here in this formula, because this is a giant calculator, no need to go elsewhere to do a calculation. So we're going to do 64 plus 1 point, I can actually say plus this value times this value, and that's going to give me 63.424. Did I do that right? It shouldn't make sense to set the mean higher than that. Oh, this one was already negative, sorry. So I have to subtract the value, 64.576. So what we would have to do in this case is set the machine to 64.57 ounces on average to ensure that more than 95% of the boxes have at least 64 ounces. So this is a nice example of a problem where we're using a computer and we still need to use the z-score formula in order to figure this out. All right, I'll see you in the next video.